in the last few weeks, we have seen how one of the state's biggest resources, Sierra snow, can turn into one of its biggest disasters. Early season runoff from warm storms sent water rushing into our reservoirs and forcing water officials to release water in anticipation for what was still going to be the spring runoff. But many of you were asking, did they really need to release all that water into our system, Monica?
That's right. So many questions. For about a year, I've been following the progress of a project called the Airborne Snow Observatory. It's out of NASA's Jet Propulsion Laboratory. I know. Sounds like a bunch of nerdy science stuff, but the research team is taking on one of the state's biggest challenges, exactly how much water we'll get from the Sierra snowpack.
It's beautiful every time, man.
Flying over the Sierra, the snow seems to go as far as the eye can see. Measuring all that snow seems nearly impossible. But in light of the Oroville Reservoir emergency, those measurements are critical, and that's why what is going on inside this plane for NASA's Airborne Snow Observatory is so important. To really see what this Airborne Snow Observatory was like, had to hit the road, and let me tell you, not an easy journey. Had to start at 3:30 in the morning, traveled to South Lake Tahoe, from there crossed over the Nevada state line, traveled down 395 for quite a while, back over onto the California side, finally making it to Mammoth, where we could see what this was all about.
We'll look in underneath.
Yeah.
And where the instruments are looking down.
This is Tom Painter, principal investigator on the project.
For a century, we've been measuring the snowpack in about the same way.
He's talking about the snow pillows and the infamous plunge of snow tubes in the Sierra.
As you can see, looking at the mountains out here, there's a lot of variability across the landscapes, and there are only so many places you can go to make those measurements.
But from the sky, it's a totally different story. Today's mission, map the San Joaquin River Basin, which will serve an area roughly from Stockton to Fresno.
We get about 40 million times more measurements. We can put together the complete picture of actually how much water there is.
Flight operations lead Dan Beresford takes us into the plane to explain the two key pieces of equipment to make this happen. First, the LiDAR.
So this shoots out laser pulses. We measure the return time of the laser pulses when they bounce off the snowpack. In doing this, we make a topographic map of the terrain.
This advanced laser is able to accurately map the snowpack within 4 inches. Next, the spectrometer.
That is essentially a spectral camera. So we're imaging the snowpack, measuring reflected sunlight. So we actually rely on the sun for that.
Snowmelt is almost entirely dominated by sunlight, not temperature. Dirty snow absorbs more sunlight and melts faster than white snow. In some of their studies, dust from the valley and even pollution from Asia has shown to drastically increase melting.
It's kind of like if we were to take a clean snowpack and move it closer to the sun than Venus.
Knowing how fast the snow will melt helps complete the picture. To get all this data, the crew flies at 22,000 feet in an unpressurized airplane wearing oxygen masks while analyzing the incoming data. Not a job for anyone who gets motion sickness.
We have all gotten sick at least once on the aircraft.
So once the flight is landed, they come over here to headquarters. This is SNARL, Sierra Nevada Aquatic Research Lab, and this is where they put all the data together. Once the flight recorders are downloaded, the research team comes up with their best estimate for snowmelt runoff. Vital information for water managers like Jeff Payne, whose area covers the central and southern San Joaquin Valley.
In the 5th year of drought, how were things going at that point?
We've gotten to the point where a couple years within there we got a 0% allocation, which is extraordinarily challenging.
Hoping to minimize those challenges, they saw an opportunity with the Airborne Snow Observatory.
Being able to predict early on that the snow is ripe and that it's coming down will allow us to move that water out and get it to where it needs to be safer than if we had to just rely on the conventional methods, which are imprecise and lead to a lot of conservative water management practices.
Which is exactly why Tom Painter hopes this project will become part of the water infrastructure not only across the western United States, but across the globe.
In terms of filling that gap, absolutely what we need, and there's no reason to go back to a time when we don't know what our resource is.